Thank you for coming. Before I even start, I want to thank the conference organizers for making this really accessible to a loud, obnoxious American. Sorry, here I am. All right, are we ready? A few years ago, I was tweaking an alert rule in the system where I was working, and I accidentally triggered 772 help desk tickets twice in 15 minutes. And the worst part about it was I didn't know that I had done it until the entire help desk came up to my cube and invited me down to their area to close the 1,544 tickets by hand. There was a mass close option. They wouldn't let me use it. With a little bit of reflection, some therapy, maybe a little alcohol, I can reflect on this formative moment and ask myself, what really went wrong? Why did that happen? I think there's enough blame to go around. Was it the operator? Was it the tool that let me do it? And what I think it comes down to is an immature idea about what alerts are. I want to thank you for coming to this talk. Alerts don't suck. Your alerts suck. My name is Adato. I am a middle-aged white dude giving a talk at a conference. For a change. And the only thing nothing about it up here is important, except you can find me as Adato on almost all the social media. And also, I did pick that suit so that you would be confident that I knew what the hell I was talking about. More importantly, what you should know is that this is what I call an oyster talk. Now, what that means is that I have 30 minutes. I cannot teach you anything in 30 minutes. In fact, about the only thing I can do in 30 minutes is irritate you. Now, when an oyster becomes irritated, it does one of two things. It creates a beautiful pearl, or it dies. I sincerely hope I do not irritate you to death. However, I felt it was a friendly gesture to let you know it was a possibility. Instead, what I hope is that I give you just a grain of an idea that you can then take with you and layer over with your own experiences and ideas until what you have is something that is the unique and valuable and personal to you. The good book, the SRE handbook, defines alerts, and it says, I have to read this, a notification intended to be read by a human and that is pushed to a system such as a bug or ticket queue, an email alias, or a pager. Now, not to blaspheme the Holy Scripture, but what the FSCK am I supposed to do with that definition? How am I left without thinking that alerts are useless and pointless? And the reason is because the SRE handbook has failed to tell me what the value of an alert is. And that's what this talk is today, is to explain to you and show you the value of alerts. Now, I'm not going to make you sit through the entire talk to get the most important part. I'm going to put the 4 most important things right up front. If you remember nothing else, here we go. The first thing, rules that handle your inbox are like assholes. Everyone has one and they all stink. If you have an inbox rule that takes all of your alert messages and throws them into a folder, you have admitted defeat. You have already stated categorically you have no intention of dealing with that alert right now. And the only time frame for alerts is right now. That's it. That's point number 1. Point number 2, welcome to this beautiful hill. It is the hill on which I am willing to die. It's called FYI alerts are trash. What is that supposed to be? Every time I ask somebody why they have an FYI alert, I get some version of, I don't do anything the first time I get the message, but if I see it 4 or 5 times in 15 minutes, then I know it's about. Tell you what, Sparky, I don't get paid for these things by the kilo. How about I give you 1 alert when it happens 4 or 5 times in 15 minutes? Okay. Number 3, I was about 8 years old. I was with my grandmother, my abuela, and we were cooking, and there was a Lipton box, and on the back of the Lipton soup box, there's a recipe, and I said, Mira, look at this, and she said, and I am quoting here, ¿Qué es esta medra? For those people who don't speak Ladino, that's, what is this shit? Yes, my grandmother swore at 8-year-old me, because this was not a recipe, it wasn't even a vague suggestion for her. Built-in alerts that come with your monitoring or observability tool are the same. They are not best practices. They are not intended to be turned on, all of them at the same time. What they are is almost vague suggestions of what the tool is capable of doing. We just want to show you, hey, did you know that when you have an alert, you can grab the top 10 processes and throw it into the message at the same time? We're not saying set off an alert when the CPU is under 80%, because that's stupid, okay? So do not turn on the alerts that come with your monitoring tool. with your monitor observability tool. Finally, with all gratitude to Charity Majors for coming up with this phrase, and I will honor it by giving the original correct phrasing. Nines don't mean shit if users aren't happy, all right? We have something today that wasn't available when I started doing monitoring 25 years ago, and that was direct data about the actual user's actual experience at that moment. So when people ask me, I'm just not even sure where to start with alerts, I'm going to tell you right now that you want to start with the user's experience. That's the thing you should be alerting on. Everything else is secondary. Now, yes, other things matter. CPU matters, disk matters, RAM matters, processes matter, number of users on the system matter. All of that matters. However, they only matter to certain people at certain times. They are not universal. The thing, the alert that should be getting you and maybe everyone else out of bed are things that directly impact the user's experience. Those are the 4 things you need to remember. All right, again, this talk is about what you need to do to have your alerts have value. I'm going to share why in the next several lessons, and the first lesson is on the fundamental nature of alerts. First of all, alerts are not the same thing as monitoring. Got it? Second, alerts are not the same thing as monitoring. And the third rule, for the love of God and pants and everything, alerts are not the same thing as monitoring. What I mean is that monitoring is nothing more and nothing less than the ongoing, regular, continuous collection of data and metrics and all of that other good telemetry stuff into your system from a selected set of targets, whether they're physical servers or applications or microservices or whatever. Doesn't matter. That's monitoring. Alerting is a very different thing. In fact, alerting and dashboards and reports are a happy byproduct of what you get when you do the monitoring first, okay? You can monitor everything. Monitor the crap out of your entire environment. That's great. Alerting should be biased toward action. Now, what do I mean by biased toward action? Let me give you an example. Every year, your boss comes to SRE Day and comes back to the office with a brand new pair of socks and a shiny new observability solution. And after you unwrap that sucker, the observability solution, not the socks, then you do what everyone does, right? You create your first alert, and your first alert is high CPU. That's what everyone does. I'm here to tell you. High CPU alerts are shit. Nobody cares if CPU is high. Nobody ever cared. It was never a problem, because you know what? If I have CPU running at 98%, but all the jobs in the CPU queue are being handled, you know what I call that? Correctly sized, right? It doesn't matter. Now, some of you at the moment are thinking, oh, here we go. Leon's old. He's going to talk about that old monitoring stuff. He's ignoring our lived experiences of dealing with a metric ton of microservices and pods of Kubernetes and all that. So not this new observability thing that we all do, right? And that's a problem, because it boils down to monitoring versus observability. And that's the wrong way to think about things. And I see that conversations about alerting get bogged down in that, when it should be monitoring and observability. So I want to take a minute and talk about some of the nuances of the differences. Now, I'm about to draw a line on the slide and a line in the sand. And I do so with the utmost respect for everyone who lost hair and stomach lining in the observability flame wars on Twitter over the last few years. And I want to be very clear that what I'm about to talk about, observability and monitoring, is only in the context of alerting. And I do that because Charity Majors is a friend of mine, and she will eviscerate me on the spot if I talk about it in any other context. But I just want to be clear about that. Okay, let's start off with monitoring. Monitoring cares about the known unknowns. We know what's going to break. We just don't know when. Fine. Also, it cares about any cardinality, meaning how unique is the information we're dealing with. Monitoring actually cares about things even if it's really regular, because disks fill all the time and other stuff happens all the time. And monitoring really does care about that, whether it's super unique or super normal or common. It's mostly manual correlation, meaning that when you want to know when a system, a collection of things are going bad, you have to know that the router bone is connected to the switch bone, which is connected to the server, the firewall bone, which is connected to the load balancer bone, and so on and so forth. You have to know that. It's not going to be built in. And finally, the signals are domain specific. What I mean by that is that the things that make a storage array look bad are specific and different from the things that make a router look bad or a microservice look bad. They are not the same things. And so the signals you're looking for are specific to a particular domain. On the other side of the slide, we have observability, which deals with the unknown unknowns. We have no idea what's going to go wrong, and we don't know when either. That's fun. Also, high cardinality events are the ones that it's really focused on, the really unique events. Also, and I'll get into this in a minute, you're dealing with a metric ass ton of data, which means that correlation has to be baked in. We'll dive into that a little bit more in a second. And finally, you have the golden signals. These are signals that indicate a system is going wrong, whether or not it's in a particular domain. That's latency. It's slow. Traffic, there's a lot of it. Errors and saturation. Those things make a system bad, slow, regardless of where or what domain it's coming from. So these are the differences. And again, I want to talk about this in the context of alerting. Now, digging in a little bit more for observability, I mentioned that high cardinality and correlation. You are dealing with a absolute pile of data. And not only is it individual data, that cardinality is dealing with unique events when they're unique on their own, but also when they're unique in combination. So you have all this data coming in, and not only we have to look at each individual thing, but also slice it from this way and that way. And the only way that you can deal with that, the only way that you can reason about that is with a machine. Now, the marketing people will call that AI, but we're at SREday, so we know that's a bullshit marketing term for 3 if statements in a trench coat. Joking aside, we cannot reason about this stuff, so you need to have a machine working on it, and that's why observability tools are built differently than your traditional monitoring tools. Now, these days, they're starting to blend, they're starting to overlap, but I just wanted to differentiate that because really, I want to get back to the idea of alerts, but I wanted to be clear about I'm going to use some simple examples because the complex observability ones will take me until next week to give you. So that's why, not because alerts only matter for the simplistic stuff. All right. So again, the point is that alerts have to matter. They have to matter to you because you're building them, but also to someone else, the person who's getting them. And they have to matter in a very particular way. I've got an algorithm for this. If and only if, meaning this all has to be true, the alert is intended to get a human, a real live actual human, to do something right now about a problem that is happening right now. If all of those things are not true, it's not an alert. It's something else. Of course, the next thing you're thinking is, okay, Leon, it's not one of those things. So what is it? By the way, I love that you're taking pictures. I am very eager to have my image up there. However, I will have these slides shared for you later, just letting you know. But feel free to take pictures, but you can also just sit back and listen. Okay. If it's not an alert, if it's not this thing, it's that thing. All right. If it's not involving a human, it's a problem right now, but it doesn't need a human, it's automation. If it's a problem, but it's not right now, and it needs a human, it's a report. Bundle it up, mail it to them later, because they can deal with it later. If it's not a problem, but a human has to deal with it, possibly right now, then it's a dashboard. Go look at it whenever you want. And if you're not going to do something about it, throw it away. Really, once again, we don't get paid by the kilo for this stuff. All right? If you're not going to do anything with it, don't have an alert because, and here's a secret, alerts are queries. That's what they are. And alerts don't just run when there's a problem. Alerts run on a cycle. They run every minute, usually, which means that every alert you have is querying all the data you have every minute. So if you have 200 alerts, you are running 200 queries against your entire data set every minute. You want to know why your monitoring system sucks? It's because you have too many damn alerts, and it's slowing the system down. All right, let's go back to that high CPU problem. I mentioned before, nobody cares about high CPU. However, if, on the other hand, what I have is that the CPU is running high, and also there are more jobs in the queue than there are CPUs to handle them, and also I see that some sort of user failure. Users are abandoning their shopping cart, or there's too many users in the system, or whatever. All right, and that thing is persisting for more than 15 minutes, let's say. Now I have an actionable, meaningful problem. All right. However, what I just said is a lot more than high CPU. And hidden within the definition of the problem are already the seeds of the solution. You already know. You're already probably thinking about it. If I had that problem, I'd probably just use Elastic and I'd add more CPUs, or I would move something over, or I'd add another device, or I'd do whatever. You already know what you're going to do about that because it's more than just high CPU. It's actionable. Issue that happens is the time frame. Everyone looks at this chart and they immediately know what they're going to alert on, right? They say, oh, there's the problem. Actually, that's not the problem. That's month-end processing where you just spike up because it's gotten busy. Or actually, it's because you were running so low over before that your elastic compute dropped a few systems, and now by reference, it looks like it's running higher, but it's actually fine. But what we all miss, you missed it, I missed it the first time I saw this, that is the exact same rise as that. It's still a 4,000 rise. But we don't see that because our human brains aren't configured to see that kind of stuff. This is where the value of having a monitoring and observability solution is there, because it's able to look at it, but only if your alert trigger factors time into the calculation. Yeah, sure, that happened once, but that's happening over a much longer period. Third pitfall is thresholds. A lot of people say, oh, CPU over 90, CPU over 95, CPU over... I don't care what number you pick, it's going to be wrong for something. And I don't care what metric you're talking about, it's going to be wrong for something. That's the problem. Instead, I would suggest using baselines. The idea of a baseline is, hey, we're collecting data on these systems anyway. How about instead of just setting a threshold, I say it's 20% more than normal, whatever normal is for that system at that time, which means that normal in this quarter might be different than normal in that quarter, which might be different than year over year, which might be but that's the concept of a baseline. Take your monitoring data, look at it over a period of time and say when it spikes over normal. Now, the problem with just baseline is that I have a few of these that still don't matter. Like, I don't care about that one. Not at all. So what do? You do both. I'd have both. Have a threshold and a baseline, meaning I'm not going to trigger until it's over a certain basic threshold, and then I'm also not going to trigger unless it is also 20% over normal, which means that in this one, I got two things that are actually going to trigger, and the rest of them are left alone. What that looks like in an actual monitoring solution, there's a screen that gives you that kind of thing. Not talking about what tool it is, it doesn't matter, but if your monitoring and observability solution doesn't do this, you might want to consider looking at one that's a little bit more robust and modern, because this is not hard. We've been doing this for years. Baseline and threshold. The fourth trap that you run into is automation. Now, Ajuna spoke about this morning. She did an amazing job of talking about some different aspects of automation and also the AI thing. But of course, again, that's 3 if statements in a trench code. But talking about automation, again, simple example, if disk is over 90%, let's say you have a volume that's more than 90%, what's the first thing you're going to do to fix it? Clear the temp files. That's what everyone does. So here's the question. Why not have the system automatically clear the temp files and then let you know if that doesn't fix the problem? That's the power of automation. And if you want proof, I actually did that at one company. It was a Fortune 20 company, $10 billion a year, something like that. And I just set the disk full alerts to clear the temp directory. And if the problem persisted for more than 5 more minutes, it cut a ticket. We dropped tickets by 300 tickets per month, which actually resulted in a savings of $80,000 a month in staff time and fixes that weren't necessary. All right. So that's the power of automation. Because honestly, one of the most important and powerful aspects of alerts is that they are there to bear witness for the problem at the moment it's occurring. So what could be more powerful on top of that than having a reaction that's immediate, that happens at the same time? Now, a question that people come up with is, yeah, but I don't know what to do. What kind of automation do I need? It's really easy. You go to the person who's getting that ticket, who's getting that alert, and say, what do you do when you get this message? And they'll say, oh, yeah, I just jump on the system. I type the Gafrinkle command, and it clears it right up, usually. Okay, hi, hey, Sparky, how about I type the Gafrinkle command for you? Gafrinkle's not a command. Those people for whom English is maybe not your first language, I do not want to cause an international issue. There is no such thing as a Gafrinkle command. Do not go onto your systems and type it. So it can go type the command for you, but you ask the person, what do they do? That's your automation. It becomes really easy. All right. And the cool part is that conversation, what do you do, usually leads to bigger insights about how the system works. So let me give you an idea of how that automation can cascade. So again, simple example, your IaaS application is running slow because I'm old and IaaS is a thing and I am ashamed of myself. But here we go. When your IaaS application is running slow, the first thing you do, the first thing everyone does, anyone who's a sysadmin for more than 15 minutes knows you clear the application pool. That's what you do. There's an automated command to do that. Why would I have a human wake up at 2 o'clock in the morning to do this? Then you wait. I don't care, 3 minutes, 2 minutes, 5 minutes, whatever it is. If the problem persists, then you restart the service because that's what you do. That's what everybody does is you restart the service and wait. Again, 3 minutes, 2 minutes, whatever it is. And if the problem persists, then you rebuild from an image, okay? Or whatever it is that you're going to do. And you wait. And then you vMotion or you move to a different zone or whatever it is that you do. But you can see that we are trying all these things. And finally, if the problem is persisting at that point, now you go wake up a human. Now you tell them that there's something to do. But you know what the power of this kind of automation cascade is? First of all, you're not getting a person involved until you have to have a person involved. And second of all, when they get involved, they know you've already done this. No, this stuff has already been done. And by the way, automation doesn't have to act on the system. It can collect information. It can say, how many users are on the system? How is a test query running? How is the ping speed from one thing to another? And you bundle up that information and you throw it into the ticket along with everything else so that when a human gets to the ticket, again, 2 o'clock in the morning is the time that I normally remember getting woken up. When they get there, they know you've tried all these things and here is the status. Here is all the information about the system at the moment of the problem. And they can get moving with their big human brain and do the things that we need humans to do. That's the real power of automation. And yeah, no AI because I'm not big on AI personally because I'm old and crotchety. However, again, this all comes from having a conversation, which takes me to the most important lesson of all, talking to people. I know this is SRE day. We don't talk to people. It's not our thing. However, it's a thing that you have to do. So you need to learn to interview now, nobody is saying that the people in your company are homicidal, psychopathic clowns. Probably. We hope. However, you need to pursue and talk to these people with the same determination as the world's greatest detective Batman on the hunt of the real killer of my app 123. You have to really dive into it and really be a detective to find out what's going on. And so you need to find the people who really care about the performance, who really care about how that application is working. And I call this the hunt for the useful alert because you're going to need to find the person who's actually living with the alert. And the funny part is the person who asked for the alert is not it. You see, the requester is the person who wants to get that alert and the application rolled into production, and they are going to lie to you because you are a roadblock on getting things rolled to prod. They will tell you anything. Oh yeah, this application is solid as a rock. It's built with unicorn spit and angel farts, and it's never going to crash ever again. What you need to do is get to the next person, the person who's actually receiving the tickets. And then you need to ask us some very specific questions. Here are the ones that have worked for me. First of all, how do you know when something goes wrong with this system? What is it? Again, they're going to say, oh yeah, I jump on the system, I type Frankel, it tells me what's going on. Great, because you know what? That's your monitoring. That's the thing that you should be including in your monitoring to be picking up that data and looking for those thresholds and baselines. Second of all, how do you know it's all better? Now, a lot of people don't think about this. They think problem goes wrong, problem not there, all better. No, again, simple example, but disk space. If I say that disk over 90 is a problem, disk is at 89%, still not okay. In fact, usually disk has to be below 80 for more than 30 minutes before I'm going to call it all done. Because otherwise you get what's called sawtoothing. It's good, it's bad, it's good, it's bad, it's good, it's bad, right? So you want to find out what does all better look like because that reversal of the trigger might be completely different than problem no longer here. Third, is there any knowledge article for it yet? All right? Because I will not roll an alert into production unless there is a knowledge base article. That knowledge base article could say, call Bob. Poor Bob, but whatever. But people go on vacation. They win the lottery. They get sick sometimes. You want to make sure that there's a knowledge article attached to the alert. And finally, can you make this happen on purpose? I learned this the same time I accidentally triggered 772 tickets because I was told that the log file, I should be looking for the word error, not realizing that the developers also had status messages of no error found. And they did it a lot, 172 times. Can you make it happen on purpose? There's one kind of alert that you don't want to do that for. When I was creating the alert to know if the network center was on fire, no, I wasn't going to do that. But there, you just reverse it. Is it not on fire? Trigger the alert. Okay, we're good. All right, can you make it happen on purpose? Now, another thing, I've been talking about the value of the alert. You have to know the value of the alert, not just to you and to the SREs and the other technical folks, but also to the business. And this is actually much easier than you might think, because you take the cost of what happens to that system without alert, how long does it take to notice and how many people are involved, versus the cost when you have the alert, how long does it take and how many people are involved. There's your difference. How many times did it happen this month, this year, this whatever? There's your value. There is nothing like going back to the business and saying, this one alert has saved you $30,000 this month. It's amazing. Now, the next question people say is, yeah, but how do I know? If you don't know, because lots of systems have the value, you know how much they're worth. If they don't tell you or you can't find out, there's a really easy way to find out. Make it up. Get it wildly wrong. People will fall over themselves. Like, oh, it's not $80,000 a minute. It's actually only $20,000 a minute. Thank you. What I needed. So that's the best way to find out the value of an alert. Okay, so we're going to summarize here. We've identified and interviewed the recipient. We've designed an alert that matters because it has a real-world trigger elements. It takes duration and baseline into account. It includes automation. And we have verified that the alert is built with the intent of immediate action by a human and communicated the value to the business. We've done all those things, right? One more lesson. This is actually the hardest lesson to accomplish, and that's that you're not done. Alerts are not one and done, okay? What I mean by that is that you cannot just set the alert, bring it out into the universe, and say it's good. You need to go back to the recipient, back to the people who asked for it or are living with it regularly, every quarter, every half year, whatever, and say, is it still doing what you expected it to do? Is there anything different about the system now than when we released this alert into production before? Are there any other things that you might want to include or other alerts that you might want? Now, some people say, oh, great, if I do well, I get punished by having to do more, but it's actually not a punishment. It's an indication of your success, because what alerts are really supposed to do at the end of the day is they're supposed to remove toil and friction and allow people to get back to the work that they meant to do, i.e. make people's weekends longer by not interrupting them if they don't have to be. Congratulations! You made it through my talk! Woo! For your patience, you get a free hat. Yes, it's the TCP/IP, but it's the AC/DC logo. Use the QR code and you can get it for free. Free as in beer, not as in puppies. I'm going to move for a minute, but I'm going to put the slide back. Don't worry. Okay, so if you're feeling irritated, I did warn you that might happen. However, I am ready for your questions. Thank you so much for taking your time with me today. And there's that slide again. Let me have it.
See, there is a lot of questions because
I'm over time.
We are out of time. I encourage you to ask questions outside the screen.
I'll be here for a little bit. I'll put this slide into the community chat, the WhatsApp chat. And also, you can find me on all social medias at Leon Adato. And again, the slides are going to be up on my GitHub repo, so you can get those there. Thank you again so much.